Hello and welcome back. So in the last video, we were just talking about why it's preferable to have paired data because we're able to kind of control, or at least able to sort of see how people vary person to person. Okay, we see some people here that are not affected at all by the intervention because they are already sort of on the upper end of things. And then we have people down here that are affected by it, but they still remain, faster than the rest. And then you have these kind of weirdos in here that behave totally differently than the rest, okay? And that paired t-test is going to account for this. It's going to kind of describe this behavior here, okay? So how do we do a paired t-test? We're actually going to be doing a paired t-test. Well, it's as easy as doing an independent samples t-test, okay? And if I just type in t.test in the old parentheses here, you're going to see that it's only asking for one thing. So we have to go ahead and supply our x, okay? The thing that we want to compare to another thing, okay? And we're going to be using this version of the data. We're not going to be doing the long version. Long versions of data are used for plotting, specifically these kind of things and these kind of things. We want to be comparing this column to this column. We want to see how that change occurs, okay? So I'm just going to go ahead and type in reaction and then the $ to grab the column that I want. And I'm just going to go ahead. I'm going to do pre because that makes the most sense to me. And then I'm going to type in y equals. And actually, let me kind of back up here. Now we see that once I supply one thing, it gives me a bunch of arguments here, options for arguments, which we'll actually get to in a moment because eventually we'll be using all of these kind of things. Okay, well, most of these things. Anyway, I want to supply then the second column. Okay, and that's going to be the post. Now, the way that this is right now, it's going to be doing an independent samples t-test because that's kind of the default version of a t-test that this function here does. We don't want to do that though. We do not want to do that. So if I hit the old comma there and hit tab, okay, so we have alternative. We'll get to that in a little bit. We have mu. We're going to get to that later too. Oh, paired. Okay. Cool. And so if I look at the little yellow box there, it says a logical indicating whether you want a paired t-test. What a logical means, if you're in computer science, then you've probably seen this before, but if you're not, that's totally fine. What this is asking for is just true or false, yes or no, okay? So if I hit tab or if I just click on it and supply a true there, so by default, this is false. So if I leave it out, that's why this does an independent sample t-test. But I want to specify that these data are paired. Okay, I want to specify that it's the same people pre and post. Okay, and that's it. Oh my gosh, that's it. Okay, so to do a paired t-test, you just have to supply this one little extra argument and you are set. Okay, so let's just go ahead and run this. Booyah. Okay, and we'll just take a look in the console here, right? This is where all the output shows up. Instead of me doing this, I think I have it on a PowerPoint. Let me, yeah, here it is. Okay, very cool, very cool. So here's the output. It's a little bit zoomed in here. There's kind of an issue here that's not a major issue, but it is, as far as interpretations go, it is an issue, at least for easiness, for ease. It's that all of these values are negative, okay? And I don't want that. We have a negative t-value. We have a negative confidence interval. We have a negative mean of the differences. We'll get to the output here in a moment. How do I fix this? Because I would like to have differences as all positive. That's a little bit easier to wrap my head around. Again, totally up to your preference. You can keep it like this. But what we're doing right here is we're saying take X and subtract Y. Okay. And in this instance, our post measurements are greater for most of them are greater than our pre measurements. Okay. And that's what a paired t-test is doing. It's just testing the difference here between between the rows, okay? Or sorry, between the columns, and kind of putting it in a different row. So essentially, I want to move these around, okay? I just want to do the larger values and then subtract the smaller values. How do I do that? Well, I can just re-specify the order here. Okay, and so now it's going to be y, take the pre and subtract. Oh, sorry. Take the x and subtract the y, okay? And so in fact, just to kind of keep things nice and organized, I'll go ahead and do that just so I don't get confused again. So we've got our post, we take the x, whatever. The x is that's just the way that the function works. That's the argument name. This doesn't really mean all too much. That's just the default argument name. And then subtract the pre, okay? Take the larger values and subtract the smaller values. And then when I run that, we'll see that we get real nice positive values, except for the p-value. P-values are always positive because they're probabilities. Notice, though, that the values themselves are still the same, okay? So a t-value of 2.68, 2.68, right? Positive here, negative there. So just a matter of order of operations here. Actually, I guess not even that, just the order in which we subtract. Okay, so let me go ahead and go back. Now, you're probably wondering, how come we didn't test the assumptions here? Well, I kind of did just in the background, okay? So we go back, we've got 10 observations per person, but they are paired, okay? So paired data is stronger than independent data. So we can actually go with even smaller sample sizes when our data are paired, okay? So having only 10 per group is totally fine. We also don't need to check the assumption of independence because these data are not independent. They are already on their own. They're paired, okay? So they are dependent, and we saw that here, right? So post is totally dependent on your pre, but the paired t-test is going to account for that, okay? It's very nice. It is very simple, very elegant, I think. And then the data are meaningfully numeric, or at least the data that we're testing. Okay, so this column is meaningfully numeric, as is this one. We're not doing anything with the ID numbers here because, well, maybe we don't so much care about, how these compare to these two columns or whatever. But also we know that these numbers here don't actually represent values; they represent people. Okay. A lot of stuff there. I'm just covering my bases, so we're not. So we're all on the same page. Okay. Let me see. Do I have this? No, I don't. Okay, so let's just go ahead and look at this output. Okay. So we have a t-value here. I'm going to get away from looking at t-values, not because they're unimportant, but just because the t-value supplies the same information that the p-value supplies, but the convention is to use p-values here. Okay. We won't worry about the degrees of freedom either. Okay, so the question is, is there a difference between the pre and post assessment? Okay, and how do we, I'm getting a call from New Jersey. Hold on, I'm going to answer this and I'll be right back. Oh my gosh, I'm so sorry. I'm back. For some reason, my phone number I think is really close to a car dealership's phone number, and I keep getting calls for estimates on like Toyota Camrys and stuff. And I'm just like, I can give you the estimate, but I'm not going to sell you one because I don't have one. Oh man, the life of Carson Keeter. Anyway, so what was I saying? Okay, the question is, is there a difference in the population of pilots after drinking? Okay, does the reaction time of pilots for all pilots, or at least a similar sort of sample, a similar subset of pilots, is their reaction time going to be different after drinking booze in the whole population? Okay, we're able to say yes, there is, because our p-value here is lower than 0.05 or 0.05. Okay, so in this case, we're saying that there is, let's see, a 2.51% chance that the difference that we saw was due to randomness. Okay. So we are able to say that yes, alcohol does affect reaction time in pilots. okay, and whatever age group they grabbed or whatever experience group they grabbed. So in the population, yes, booze does affect reaction time. Okay, so that's the yes or no aspect of it. Now, what is the difference? How are we able to then kind of quantify that difference? Well, we're not able to say it's going to be 195.6 milliseconds each time, right? Because this is just the mean of our sample, the mean of the differences of our sample, okay? That's all that's saying, okay? But what we are able to say is that we are 95% confident, or there's a 95% chance that if we were to go out and get a similar size sample an infinite amount of time, 95% of the time, that difference from pre-booze to post-booze, that reaction time difference is going to be from 30.69 milliseconds to 360.5 milliseconds. Okay, so it goes up. That difference between pre and post booze, that difference for the whole population is going to be contained in this interval. Okay, in this interval. So we are able to say that booze does affect reaction time, and that interval is contained, or sorry, that reaction time, that the difference there is going to be contained in this interval. Oh my gosh. Now, we kind of have, I think I mentioned this in the last one. If I didn't, that's fine. We have the alternative hypothesis here. It tells us that, the true difference in means is not equal to 0. And that's what we want to test. Because if there is no difference, if the difference equals 0, right, then that means that there is no difference. Okay, so there is no difference, at least, largely between the pre and post booze. Okay. Boy, what is the next slide here? Okay, so here's what I want to do next. I'm going to stop the video and I'm going to show you how we can recreate this with just a single column of data. Okay, and I've already kind of hinted at what this is doing in the background here and sort of set it right here. But I'm going to show you how to do it in a slightly simpler way with just a little bit of arithmetic. Okay. So I'll pause the video, just take a look at this again, kind of get your head wrapped around it. The interpretations stay the same across all the different t-tests, but the way that we do it, the code that we write is going to be slightly different depending on the data that we have. Okay, so with that, I will see you in the next one.